Okay, now let's talk about how to identify aromatic rings. So aromatic rings only have these three characteristics. If all these three are present, then it's going to be an aromatic ring. So the first one is an unbroken ring of p orbitals. The second one is a specific number of electrons, that's 4n plus 2 pi electrons. And the third one is its planar. So what do I mean when I say a ring of p orbitals? Well, if something's sp2 hybridized, so like this carbon right here is sp2 hybridized, right? That means that there's a p orbital that's not being used in the hybrid system. There's an extra p orbital. So I drew that p orbital in. And actually all these are sp2 hybridized. So all of those have an extra p orbital that's not being used in the hybridization. So I drew in all those p orbitals here so you can see there's a ring, an unbroken ring of p orbitals. Now, if just one of these wasn't sp2 hybridized, if it was sp3 hybridized, it couldn't be aromatic. So I'll give an example of that. See, this ring down here has two carbons that are sp3 hybridized, so they don't have an extra p orbital, so this cannot be aromatic because of that. So that's what I mean when I say a ring of p orbitals. The next thing is 4n plus 2 pi electrons. So when I say pi electrons, that specifically means electrons that are going to be present in double bonds, or if they're a lone pair that can be in a p orbital. So they're electrons hanging out in p orbitals. You could have also heard double bonds being called pi bonds, that's why. So in this case, we have 1, 2, 3 pi bonds. Each bond is made up of 2 electrons, so there are 6 pi electrons present. It's worthwhile for you to check and make sure that you can identify what are pi electrons and what's not, but once you get the hang of it, it'll come really naturally for you. So we have 6 pi electrons. Does that count as 4n plus 2 pi? Well, what we mean when we say 4n plus 2 pi is just, if this n was any number, plug in any number, is that how many electrons we have? So here's 4 times 0 plus 2 is 2 electrons. We don't have 2 electrons. 4 times 1 is 4, plus 2 is 6, so 6 pi electrons, that's what we have. If we had 10 pi electrons, 14 or 18, or so on, any of those would be an appropriate number. So far in this benzene ring, we have a continuous ring of p orbitals. We have 4n plus 2 pi electrons coming in at 6. And then the next question is its planar. So in my experience, if it meets 1 and 2, it's usually going to be planar, with the exception of something known as tin aniline. We can talk about that later, but for now, I want you to focus on making sure you understand these first two criteria, and then you'll have a good understanding of how to approach aromatic rings.